Making sure everything's all signed in. Hello, hello. Hope everyone's doing well. Hope everyone is doing well. Let's see here. There we go. Okay. So it looks like I'm all set, ready to go. And let me make sure that we have home live. Just signing into 28 seconds ago. Good, good. Make sure the volume's good. Testing 1, 2, 3. Yep. All right, volume's all set, ready to go. Hello, everybody. So today is August 20th, 2026. It is currently almost 2 o'clock. It's 1:59 where I am. And this is the second practice stream or second study stream that I'm doing today. And it's just good old copywork, crazy as always. And we're copying through Augustus De Morgan's Elements of Arithmetic. It's essentially a pre-algebra. The Elements of Arithmetic is a little bit misleading, but it's the purpose of reviewing the arithmetic, and primarily it is also the use of arithmetic to learn and to acquire practice in Gregg Anniversary shorthand. This is by no means, I want to say this, I have to say this time and time again, this is by no means a viable nor a smart mode of study. You should not copy. You should not copy long passages of text and hope to understand anything. It simply is going to be a waste of your time and a waste of your attention. You'd be much better served if you are wishing to engage with study. You'd be much better served to read through a paragraph, or in this case, the articles, as these books, as this particular book has, and to then write a summary of the particular chapter, or like your key thoughts, your takeaway. So I am demonstrating Gregg Shorthand, the Gregg Shorthand copywork, not to say that this is the correct way to go about learning a textbook, but it is one way, especially if you are interested, as I am, in the learning of a new system of writing. Gregg Shorthand is essentially a form of language, such as American Sign Language or Morse code, and so therefore you have to treat it almost as a language study. Okay, so with that being said, I'm going to go ahead and get to work. Currently on article, as you see here, I'm currently in article 100. It's a fairly long one. There are two fractions. They're doing all the examples here. It's article 111, okay? And then 112 takes on afterwards. So let's go ahead and pull back to where we were previously. Get the whole level in here. Move over in our Zernal. If you're interested in any of the links, they're all in the description down below. So there's links you can support me if you wish. You can grab yourself a copy of the PDF of the book. It's a good old textbook. If you want to learn a little bit more about Gregg Anniversary shorthand, there's information down there as well. So without further ado, let's get a crackin', shall we? So let me go ahead and figure out what we were looking at last, which was fractions. The first fraction, the first fraction. We had just done 1/10 and 5/6, right? So that was right here. The first fractions. Okay. Just check this out here to turn my volume down. Okay. All right. Ready to go. Observe that also that 540, so it's where we left off. So we have the question, then the first, the question, then the first fraction. So the then is a little too pronounced. Okay. Observe also that 540 is one common multiple of 10, 6, and 9. Namely, 10 times 6 times 9. But that 90 is the least common multiple. And that's the LCM. So we can do LKM in order to demonstrate that, is the least common multiple of 10, 6. 90 is the least common multiple of 10, 6, and 9, and that's according to Article 103. The following process, therefore, is better. To reduce the fractions 1/10, 5/6, and 7/9, to others having the same value and a common denominator. Begin by finding the least common multiple of 10, 6, and 9. Let's go ahead and add another page below this. Section 5, Elements of Arithmetic, Section 5, and this is page number 7. Okay, let's go ahead and go back up. Okay. The least common multiple of 10, 6, and 9 by the rule in 103, which is 90. Article 103, which is 90. Observe that 10, 6, and 9 are contained in 90, 9, 15, and 10 times. Are contained in 90, 9, 15, and 10 times. They are contained. Observe that those three are contained in 90, 9, 15, and 10 times. Multiply both terms of the first by 9. Of the second by 15. And of the third by 10. Comma, and the fractions thus produced. Are 9 over 90. $75 over 90. And 70 over 90. The same as before. New paragraph. If one of the numbers be a whole number, it may be reduced to a fraction having the common denominator of the rest. By Article 106. And then we have some exercises following that. So let's go ahead and read over. Let's go ahead and read over the section that we just covered, which was 111. Okay. Zoom back over here in Journal, find 111. all those examples there. Earlier, there's 110, there's 111 right there. Okay, let's go ahead and highlight. And we begin. As we can, by Article 108, multiply the numerator and denominator of a fraction by any number without altering its value, we can now readily reduce two fractions to two others, which shall have the same value as the first two, and which shall have the same denominator. Take the example 2/3 and 4/7, or 2/3 and 4/7. Multiply both terms of 2/3 by 7 and both terms of 4/7 by 3. It then appears that 2/3 is 2 times 7 over 3 times 7, or 14/21. 4/7 is 4/7 times 3/3, or 12/21. So let's do the dot there, the aspirate. Here are the two fractions, 14/21 and 12/21, equal to 2/3 and 4/7, and having the same denominator, 21. In this case, 2/3 and 4/7 are said to be reduced to a common denominator. It is required to reduce 1/10, 5/6, and 7/9 to a common denominator. Multiply both terms of the first by the product of 6 and 9, of the second by the product of 10 and 9, and of the third by the product of 10 and 6. Then it appears, according to 108 again, that 1/10 is equal to, if you do all this math here, then it's equal to 54/540. 5/6 appears to be 450/540, and 7/9 appears to be 420/540. On looking at these last two fractions, we see that all the numerators and the common denominator are divisible by 6, and according to 108, this division will not alter the values. On dividing the numerators and denominators of 54/540, 450/540, and 420/540 by 6, the resulting fractions are 9/90, 75/90, and 70/90. These are fractions with a common denominator, and which are the same as 1/10, 5/6, and 7/9. And therefore, these are a more simple answer to the question than the first fraction. Observe also that 540 is one multiple of 10, 6, and 9. Namely 10 times 6 times 9. But that 90 is the least common measure of, or is the least common multiple, is the least common multiple of 10, 6, and 9, according to 103. The following process is, therefore, is better. To reduce the fraction 1 over 10, 5 over 6, and 7 over 9 to others having the same value and a common denominator, begin by finding the least common multiple of 10, 6, 9 by the rule in 103, which is 90. Observe that 10, 6, and 9 are contained in 90, 9, 15, and 10 times. Multiply both terms of the first by 9, of the second by 15, and of the third by 10, and the fraction thus and the fraction thus produced and the fractions thus produced are 9 over 90, 75 over 90, and 70 over 90, the same as before. If one of the whole numbers be a whole number, it may be reduced to a fraction having the common denominator of the rest. By Article 106. All right, moving on to 112. Moving on to 112. By reducing two fractions to a common denominator, we are able to compare them. Let me check compare. That is to tell which is the greater and which is the less of the two. For example, take 1/2 and 7/15. These fractions reduced without alteration of their value to a common denominator are 15 over 30 and 14 over 30. Of these, the first must be the greater. Because according to 107, it may be obtained by dividing 1 into 30 equal parts. And taking 15 of them. But the second is made by taking 14 of those parts. It is evident that of two fractions that have the same denominator, the greater has the greater numerator. And also that of two fractions which have the same numerator, the greater has the less denominator. Thus, 8 over 7 is greater than 8 over 9. Since the first is a seventh, is a seventh, and the last only a ninth part of 8. Also, any numerator may be made to belong to as small a fraction as we please. Belong is one that, is it just B, B-E? B-L and then N-G? To as small a fraction as we please. By sufficiently increasing the denominator. Ooh, sufficiently. Suf. S. There we go. Increasing the denominator. Thus, ten over 100 is 1 over 10, 10 over 1,000. Thus 10 is 1 over 10. 10 over 100 is 1 over 10. 10 over 1,000 is 1 over 100. And 10 over, what is that, 1 million? Yes. There we go. Is 1 over 100,000. There we go. And that was still according to Article 108. Okay, and that's the end of the paragraph. We continue to get to the end of Article 112, and then we go on to Article 113. Okay, here we go. We can now also increase and diminish the first fraction by the second. New article. We can now also increase and, what's diminish? And, dimish, I think, right? DM-ish. Checky check. That's right. We need to have the E thrown in there as well. Good. we can now also increase and diminish the first fraction by the second. For the first fraction is made up of 15 of the 30 equal parts. For the first fraction is made up of 15 of the 30 equal parts into which 1 is divided. The second fraction is 14 of those parts. Oh, let's add another page. Page number 8. Elements of Arithmetic. Section 5. It's a good problem to have. Moving through the pages this quickly means I'm going faster. The second fraction is 14. Hold on, what am I looking at? Is 15 of the 30 parts into which 1 is divided. The second fraction is 14 of those parts. The sum of the two, therefore, must be 15 plus 14. Or 29 of those parts. That is 1/2 plus 7/15 is 29/30. The difference of the two must be 15 minus 14, or the delta of 15 and 14. The difference of the two must be 15 minus 14, or 1 of these parts. That is 1/2 minus 7/15. Is going to be equal to 1/30. All right, and that is the end of that article, Article 112. Let's go ahead and read back over it. All right, where are you, my friend? I'm looking, 111, 111. Oh, there it is, 112. Let's go ahead and get started, but let me grab a quick drink of water first. All right. By reducing two fractions to a common denominator, we are able to compare them. That is, which is the greater and which is the less of the two. For example, take 1/2 and 7/15. These fractions reduced without alteration of their value to a common denominator, or 15/30 and 14/30. Of these, the first must be the greater, because according to 107, it may be obtained by dividing 1 into 30 equal parts and taking 15 of them by the second, but the second is made by taking 14 of those parts. It is evident that of taking two fractions which having the same denominator, the greater has the greater numerator, and also that of two fractions which have the same numerator, the greater has the less denominator. Thus 8/7 is greater than 8/9, since the first is a seventh, and the last only a ninth part of 8. So a seventh part of 8 versus a ninth part of 8. Okay? A seventh part of something is greater. Also, when any numerator may be made to belong to as small a fraction as we please, but is sufficiently, is that what it is? But is sufficiently, what are they saying? By sufficiently. Oh, that's a mistake right there then. Oh yeah, because I was trying to write out sufficiently. Jumped the gun. So we'll do here. There we go. Okay. By sufficiently increasing the denominator thus. 10/100 is 1/10, 10/1000 is 1/100th, and 10/1,000,000 is 100,000th, according to Article 108. We can now also increase and that's not demonstrate. We can also increase and demonition. Our definition? No. Diminish, that's right. And diminish the first fraction by the second. For the first fraction is made up of 15 of the 30 equal parts, into which 1 is divided. The second fraction is 14 of the parts. The sum of the two, therefore, must be 15 plus 14, or 29 of the parts. That is, 1/2 plus 7/15 is 29/30, 29/30. The difference of the two must be 15 minus 4, or it of these, hold on, or 1, oh, duh, There we go again, thinking that it is a Gregg character. It's not, it's 1. Or one of these parts. That is 1/2 minus 7/15, or which is equal to 1/30th, which is equal to 1/30th. Okay, now let's go on to Article 113. From the last 2 articles, the following rules are obtained. Number 1. To compare, to add, or to subtract fractions, first reduce them to a common denominator. When this has been done, that is the greatest of the fractions which has the greatest numerator. Let me check greatest. Yeah, it needs S and T. Greatest. Let's fix those 2. Greatest. The greatest of the fractions, which has the greatest numerator. Okay? Their sum has the sum of the numerator for its numerator. And the common denominator for its denominator. Their difference has the difference of the numerators for its numerator and the common denominator for its denominator. there we go. And that's the end of Article 113. And then, of course, we have the exercises as well, adding and subtracting fractions that have different denominators. Okay, so let's go ahead and read back over that. So 113. From the last two articles, following the following rules. The following rules are obtained. Number one, to compare, to compare, to add, or to subtract fractions. First, reduce them to a common denominator. When this has been done, that is the greatest of the fractions, which has the greatest numerator, their sum has the numerator for its numerator and the common denominator for its denominator. Their difference has the difference of the numerators for its numerator and the common denominator for its denominator. All right, very nice. Let's go on to 114. Grab a little sip of water first. Okay, and let's go to 114. Scroll down the page a little bit. Zoom down, there we go. And let's add a paragraph marker here. Boom, and 114 is what we're looking at. Here we go. Suppose it required to add a whole number to a fraction. Suppose it, and let me check suppose again. I think it's just SPO, but can never be quite, yeah, there we go. Yep, suppose it required to add a whole number to a fraction, for example, 6 to 4/9. By Article 106, six is 54/9. And 54/9 plus 5/9, or no, 4/9, my mistake. 4/9 is 58/9. That is, once it has been reduced, 6 4/9. That is 6 plus 4/9, or as it is usually written, 6 4/9 is 58, or as it is usually written, 6 4/9 is 58/9. The improper fraction. The rule in this case is multiply the whole number by the denominator, of the fraction, and to the product add the numerator of the fraction. The sum will be the numerator of the result and the denominator of the fraction will be its denominator. Thus, 3 1/4 is equal to 13/4. 22 5/9 is equal to 203/9, 75 and 50 seconds, or is it 74? 74 and 2/55 qualify for AARP, is equal to 4,072/55. All right, so 4072 over 55. This rule is the opposite of that in Article 105. This rule is the opposite of that in Article 105. There we go. All right, so that takes care of all of 114, correct? Yes, and then 115 takes over. So let's go ahead and read back over 114. Grab a little bit of water first. Zoom up the page. And we're looking for there it is, 114. We start. Suppose it required to add a whole number to a fraction. For example, 6 to 4 over 9. By Article 106, 6 is 54 over 9, and 54 over 9 plus 4 over 9 is equal to 58 over 9. That is 6 plus 4 over 9, or as it is usually written, 6 or 4/9 is 58 over 9. The rule in this case is multiply the whole number by the denominator of the fraction, and to the product add the numerator of the fraction. The sum will be the numerator of the result, and the denominator of the fraction will be its denominator. Thus, 3 1/4 is 31 over 4, 22 5 over 9 is 203 over 9, 74 and 2 over 55 is 4072 over 55. This rule is the opposite of that in Article 105. Now let's continue. To Article 115. Oh. And yeah, that's positioned well. Good. Article 115. From the last rule, it appears that and then we have a value here, 1,723. And 23 and 907 over 10,000 it looks like, so we need 4. Yep. Is, and I cannot make that number out. Sheesh. Oh, okay, so that's just the ciphers issue, so we can easily add ciphers to that. So we simply add the value. So if it is a base 10, then it's a simple matter of simply tacking the whole number on. So this one, this value, this mixed number in improper fraction would be 1, or compound fraction, I think is the other term for it. 1723907 all over 10,000. Okay? So you see that? You simply add the whole number to the value. You tack it on, and that's how you get a compound fraction for mixed numbers if your base value is some sort of base 10. 667, for instance. 667 and 225 1,000ths is going to be equal, is simply add the units to it. So you go 667, 667, 225, all over 1,000. All right? And 23, 99, is that 100 thousandths? No, yes, 100 thousandths. 100 thousandths is going to be, you simply add it on, 23. Now here's where it gets interesting. You have to add extra zeros. 23, like so. All right? 23,000. Oh yes, because it has to be the same number. 23, 3 zeros, 99, all over 100 thousandths. There we go. Hence, when a whole number is to be added to a fraction, whose denominator is 1 followed by ciphers, whose denominator, a fraction, whose denominator is 1 followed by ciphers. The number of which is not less than the number of figures in the numerator. The number of which is not less than the number of figures in the numerator. The rule is I need to add another page. Drifting up a little bit. Elements. section 9. Okay. The numerator, number of figures, and it's underlined. In the numerator, comma, the rule is write the whole number first, and then the numerator of the fraction. With as many ciphers between them as the number of ciphers with as many ciphers with as many ciphers between them as the number of ciphers in the denominator between them as the number of ciphers in the denominator exceeds the number of figures. I think that's exceeds. Let's go and check it. Yes. The number of figures in the numerator. The number of figures in the numerator. This is the numerator of the result. And the denominator of the fraction is its denominator. If the number of ciphers in the denominator be equal, to the number of figures in the numerator, write no ciphers between the whole number and the numerator. And then we have the exercises. So let's go ahead and read through that and then get back to work. Oi. And let's reduce the following fractions, mixed quantities to fractions. Let's go ahead and read back over 115 before we copy down 116. There we are. From the last rule, it appears that 1,723 and 907 over 10,000 is 172,360.7 over 10,000, 667, and 225 over 1,000 is then 667,225 thousandths, I guess, and 23 over 99 hundred thousandths is 23. Notice this is the example where you have to put more ciphers in the answer in order to pad it out, so you have the same number of zeros or ciphers as they're called. What word is that? Hence, when a whole number is to be added to a fraction whose denominator is 1 followed by ciphers, the number of which is not less than the number of figures in the numerator, the rule is write the whole number first and then the numerator of the fraction with as many ciphers between them as the number of ciphers in the denominator. The denominator exceeds the number of figures in the numerator. Thus, this is the numerator of the result, and the denominator of the fraction is its denominator. If the number, if the number of ciphers, I think I've forgotten of. Yeah, there we go. If the number of ciphers in the denominator and it, be equal to the number of figures in the numerator, write no ciphers between the whole number and the numerator. Yay! All right, so we got that. Let's go to 116. Zoom down, add a paragraph marker. 116. Suppose it required to multiply 2/3 by 4. Here we go. Suppose it required to multiply 2/3 by 4. This by taking Article 48, this by Article 48 is taking 2/3 4 times. 2/3 4 times. That is finding. Here we go. That is finding 2/3 plus 2 over 3 plus 2 over 3 plus, and I can't squeeze it in, so we'll put it in here, plus 2 over 3, period. This by Article 112. This by, I wonder, can we do this by, yeah, that works. This by Article 112 is 8 over 3. So that to multiply a fraction by a whole number, the rule is a fraction by a whole, oop, there we go, a number, let's make that in just a little bit nicer. A fraction by a whole number, the rule is colon, multiply the numerator by the whole number, multiply the numerator by the whole number, and let the denominator alone. Oh, remain. Remain. There we go. All right. Suppose it required, and boy, that's easy. We can just read over that in no time at all. Oi. Okay. So back up to 116. There we go. Here we go. Suppose it required to multiply 2/3 by 4. This by Article 48 is taking 2/3 4 times. That is finding 2/3 plus 2/3 plus 2/3 plus 2/3. This by Article 112 is 8 over 3. So that to multiply a fraction by a whole number, with that, I don't really like that whole number. There we go. A whole number. The rule is multiply the numerator by the whole number, and let the denominator remain. Yay! All right, so 117. Here we go. New paragraph marker. If the denominator of the fraction be divisible by the whole number, if the denominator of the fraction be divisible by the whole number, the rule may be stated thus. The rule may be stated thus. Divide the denominator of the fraction. Divide the denominator of the fraction by the whole number. And let the numerator remain. And let the numerator remain. For example, multiply 7 over 36 by 6. For example, multiply 7 over 36 by 6. This, according to Article 116, is 42 over 36. Which, since the numerator and denominator are now divisible by 6, is, according to Article 108, the same as 7 over 6. It is plain that 7 over 6 it is plain that 7 over 6 is made from 7 over 36 in the manner, what is manner? Okay, there's manner. Stated in the rule. Period. End of paragraph. Read back over. Rule 117. If the denominator of the fraction be divisible by the whole number, the rule may be stated thus: divide the denominator of the fraction by by the whole number, and let the numerator remain. For example, multiply 7 over 36 by 6. This, according to Article 116, is 42 over 36, which, since the numerator and denominator are now divisible by 6, is, according to Article 108, the same as 7 over 6. It is plain that 7 over 6 is made from 7 over 36 in the manner stated in the rule. All right, next article. Multiplication has been defined to be so we go multiplication has been defined is, let's see what defined is. There we go. Is defined. Has been defined. Multiplication has been defined to be the taking as many of one number as there are units in another. Thus, to multiply 12 by 7 is to take as many 12s as there are units in 7. Or to take 12 as many times as you must take 1 in order to make 7. Thus, what is done with 1 in order to make 7 is done with 12 to make 7 times 12. Is done with 12 to make 7 times 12. For example, and then it shows 7 is 7 groups of 1, right? And then 7 times 12 is 7 groups of 12. When the same is done with 2 fractions, here's our next section, for example, and then I'm just going to say in here, consult textbook. Okay, new paragraph. When the same thing is done with two fractions, the result is still called their product. Add another line below. Result is still called their product. The result is still called their product, and the process is still called multiplication. There is this difference. That whereas a whole number is made, by adding 1 to itself, a number of times. A fraction is made by dividing 1. Into a number of equal parts. And adding one of those parts to itself a number of times. This being the meaning of the word multiplication. As applied to fractions. It's spinning. Hold on. Getting close to the end, though. I think, yeah, I'll just power through. Let's just power through. Come on. Oh, got this. Okay. Okay. This being the meaning of the word multiplication as applied to fractions, what is 3 over 4 multiplied by 7 over 8? What is 3 over 4 multiplied by 7 over 8? Whatever is done with 1 in order to make 7/8 must be done with 3 over 4. Okay? Whatever is done with 1 in order to make 7/8 must be done with 3/4 to make 7/8. 1 is divided into 8 parts and 7 of them are taken. But to make, must be done with, whatever is done with 1 in order to make 7/8 must be done with 3/4. But to make 7/8, 1 is divided. There we go, I missed a part. But to make 7/8, comma, 1 is divided into 8 parts and 7 of them are taken. Therefore, to make 3 over 4 times 7 over 8, 3 over 4 must be divided oh boy, hold on. I can't think right now. Let me grab a little sip of water. Oh man. Okay. must be, where are we? Must be divided into, therefore, to make 3 over 4 times 7 over 8, 3 over 4 must be divided into 8 parts, and 7 of them must be taken, and 7 of them must be taken. Now 3 over 4 is now 3 over 4 is by Article 108 the same thing as 24 over 32. The same thing as 24 over 32. Since 24 over 32 is made by dividing um, 1 into 32 parts. Oh man. And taking 24 of them, which is the same thing, which is the same, oh man, which is the same thing, comma, taking 3 of them 8 times, taking 3 of them 8 times, if 24 over 32, if 24 over 32 be divided into 8 equal parts, each of them is 3 over 32, and if 7 of these, and if 7 of these parts be taken, the result is 21. The result is 21 over 32. And the same reasoning may be applied to any other fraction. And the same reasoning may be applied to any other fractions. But 21 over 32 is made, but 21 over 32 is made from 3/4 and 7/8 by multiplying the two numerators together for the numerator and the two denominators for the denominator and the two denominators for the denominator, which furnishes a rule for the multiplication of fractions. And what is furnish? What is furnish? Oh, let's check it out. Oh, yeah. Oh. Here we go. Okay. Which furnishes a rule for the multiplication, a rule for the multiplication of fractions. Oh, okay. Wow. Let's go ahead and read through 118, and then I don't know if I'll have time to be able to get to 119, but hey, that was quite the copy. What was that, like a full page? Yeah, there's 118. Almost a full page. Let's go, and then we'll take a break. Here we go. 118. Multiplication has been defined at to be the taking as many of one number as there are units in another. Thus, to multiply 12 by 7 is to take as many 12s as there are units in 7, or to take 12 as many times as you must take 1 in order to make 7. Thus, something done? Thus to multiply, thus what is done with 1 in order to make 7 is done with 12 to make 7 times 12. For example, and then this consult textbook, when the same thing is done with 2 fractions, the result is still called the product, and the process is still called multiplication. There is this difference that arises at in whole numbers is made by adding 1 to itself a number of times. A fraction is made by dividing 1 into a number of equal parts and adding 1 of those parts to itself a number of times. Okay. So a number of times. This being the making of the order of the word multiplication that applied to fractions. What is 3 over 4 multiplied by 7 over 8? Hold on, what's it saying? Whatever, I don't think that's whatever, but I'm out of time. Whatever is done with 1 in order to make 7 over 8 must be done with 3 over 4, but to make 7 over 8 1 is divided into 8 parts and 7 into and 7 something, or taken. Therefore, to make 3 over 4 times 7 over 8, 3 over 4 must be divided into 8 parts, and 7 of them must be taken. Now, 3 over 4 is, by Article 108, the same thing as 24 over 32, since 24 over 32 is made by dividing it into 32 parts and taking 24 of them, which is the same thing, taking 3 of them 8 times. If 24 over 32 be divided into 8 equal parts, each of them is 3 over 32, and if 7 of these parts be taken, the result is 12 over 32, and the same reasoning may be applied to any of the fractions, but 12 over 32 is made from 3 over 4 and 7 over 8. Multiplying the two numerators together is the numerator, and the two denominators, what is that? For the denominator, which furnishes a rule for the multiplication of fractions. Okay, that is it for 119. Feel like I'm getting kind of close. I have 119, 120, 130, 140. Yeah, I know I'm not going to get done today, but we just keep on plugging away. So when I come back in about 40 minutes to an hour, I'm going to go ahead and do another 2-hour session, and we're going to start in on number 120, article number... Oh, man. I think it is article number 120, right? Yes. No, it's not. It's article 119? Yeah, article 119. All right, so thank you so much. I hope everyone is having a good evening, and we just keep on plugging away. So thank you so much. I'll see you in a little while. Bye-bye.